What's up, friends? It's Andrew again, and in this video we are going to be tackling the infamous question number 57 from the math test inside test 2 in your red book. So take a second, pause the video, go ahead and read question 57, and when you have done so, hit play. Okay, now guys, this problem I love it. I'm a huge math nerd. I love this problem. It's about these things called vectors. Now here's the long and short of vectors. Vectors are typically, well, at least for me, I learned them in Calc 2. Okay, I learned these things way at the end of Calc 2. They are not kind of a typical thing that you use all the time in your math classes. This is kind of an odd branch of high school math. So a lot of us probably haven't seen vectors before. We don't know about the unit vector. We don't know about vector operations. And if that's you, that's okay, because the vast majority of people probably don't learn this stuff by the time they take the ACT. So if you haven't seen all of this vector nonsense before, again, this is one of those questions that's not going to be low-hanging fruit for you. You don't want to get stuck on a question that you know you can't answer, so this might be one that you skip, maybe even end up guessing on, and that's okay. But we're going to walk through the solution to this problem. I'm not going to spend a ton of time diving into the depths of vectors, but let's walk through how to solve this problem. It gives us a picture with a couple of different vectors in the picture. One vector is called AB, the other is called CD. I didn't draw the picture, but here's how you kind of deal with vectors. A vector has parentheses. It's almost like a coordinate, except instead of parentheses, it has these kind of triangular looking brackets. And the first piece of your vector is how much your vector moves to the right or to the left. So let's look at vector AB first. You'll notice the arrow for vector AB, from start to finish, it moves to the right by 9 units. Doesn't matter where it starts and ends, we know it moves to the right by 9 units. And we also know it moves up 6 units. So our vector AB moves positive 9 and up 6. Our vector CD, same kind of brackets. Our vector CD, excuse me, does not move at all in the left or right direction, but it moves up by 5. So our vector AB moves to the right 9 and up 6. Our vector CD does not move to the left or right at all, but it does move up by 5. Now these are our two vectors, and it wants us to say something about AB plus CD, okay? Now, I'm gonna do it one way, and then at the final step, we're gonna work backwards for a second. I think this is the easiest way to think about this. When you add vectors together, it's very simple. You add the x components, and then you add the y components. So AB plus CD, if we add those two vectors together, our new vector, the x component of it is the x component of our first vector plus the x component of our second vector. So 9 plus 0 is 9. And when we add, again, we just add for the y component, we add the y component of the first vector plus the y component of the second. 6 plus 5 is 11. So if I was to take those two arrows in the picture in your book and add them together, it would produce an arrow that moves to the right by 9 units and moves up 11 units. And this is the vector AB plus CD. But the problem is the answer choices look completely different than this. They look completely different than this. The answer choices use these things called unit vectors. Super annoying, okay? I bet just by looking at the answer choices, knowing this information, you could figure it out. It's the only one that has a positive 9 and a positive 11. But I want to show you why. The unit vectors are often called I and J. I is a unit vector, meaning it moves, they call it a unit vector because it moves by 1 unit. The I unit vector is 1, 0, and the J unit vector is 0, 1. So in the answer choices, where it says 9i plus 11j, check this out. This is really what's happening. We are multiplying 9 times the unit vector I, which is 1, 0. So 9 times 1 is 9, and 9 times 0 is 0. So 9i is actually the vector 9, 0. And let's look at 11j here. 11j. We have 11 times the unit vector j, which is 0, 1. Now, 11j, so this is equal to 9i. 11j is 11 times 0, which is 0, comma, 11 times 1, which is 11. 9i plus 11j is these two vectors added together, which is 9 plus 0, which is 9, 0 plus 11, which is 11, which is the vector that we got when we added these two original ones together. So you can see this all goes in a big circle here. But the bottom line is, how do we, I say this to show you that this is the vector that we get. This is the vector that we get when we add A, B, and C, D together. But in order to put it in the form that the answer choices want, we have to use these unit vectors, I and J. The answer is this guy right here, 9i plus 11j. And I just wanted to show you this stuff at the bottom to show you why that is the case. But 9i plus 11j is the same thing as this vector, 9, 11. So 9i plus 11j is answer choice E. There you go.